He's all alone. There's no one there beside him. Parker. So it's all good. All right, so we want to evaluate this integral using the graph of the function. The main reason we want to do that is we actually couldn't evaluate that square root of 16 minus x squared. We don't have enough stuff in it to make it happen, so we would have to do this one graphically. First of all, what is that? It's a semicircle. What have we done with it? Yeah, we pushed it up a little bit, right? How much did we push it up? 5. So we push it up 1, 2, 3, 4, 5. And then what's its radius? 4. 1, 2, 3, 4. Okay, so here's my picture, all right? And it wants the integral from 0 to 4. So basically I want this portion. Okay, so how could we find that integral using this graph? Yeah, let's just do all the area, all right? All the area that's under that curve. So if we do geometry, up here I'm going to have how much of a circle? A fourth. Here I've got a rectangle, which is just going to be length times width. And so if we fill in all of those missing pieces, the top one be 1/4 pi times 4 squared. Length times width would be 4 times 5. So we're going to get 20 plus, that's going to be 16, 4 pi. And there is the value of your integral. Okay, so using geometry a little bit right there. Okay, there are copies on the back table if you needed to get one. All right, I just put those out. I apologize that I took so long. All right, so just do an area. Switch to a vanilla caramel creamer. It's excellent. Do what? Yep. All right, let's look at our affirmation today. It says, you may encounter many defeats, but you must not be defeated. In fact, it may be necessary to encounter the defeat so you can know who you are, what you can rise from, how you can still come out of it. Okay, that's inspiring. All right, today we're going to talk about the average value of a function. All right, average value of a function. And we're going to do so by talking about what's called the perfect rectangle, finding the perfect rectangle. So in the past, we used many rectangles. Remember when we did all the different rectangles to estimate the area underneath a curve. Today, we're going to explore a slightly different question. Is it possible to find one rectangle that has the same area as the area underneath the curve? And if so, how do we find this perfect rectangle? Okay, so there are 6 questions that it's going to lead you through. So let's take some time with our table groups and let's walk through those. And then we'll talk about how we find average value. I look like I work at beach today. Said I put this on and I was like, I look like I work at beach today with my orange and blue.
How did we get there? There's no logical conclusion here.
Walk. Did you replace? You did not replace the water bottle.
Not yet.
Are you still in mourning, or are you better?
Better than Monday.
Okay. Because you were laid all the way out in the floor. Yeah.
Well,
Yes, that's what that was about.
Not much of it's spilled. It's because it was like in the parking lot, so I didn't have to worry about it. It's not over. And by the time I got inside, I was just like at the bottom. So you just like hold it upside down. Oh yeah, I did take attention. I forgot. I did to the point where it cracked right here, but then I went to the bathroom to see if it was recoverable, and I ended up then I just trashy. No, it's not that one.
Whew. All right, so let's take a look at these and just kind of walk through it, trying to come up with the perfect rectangle. So on the first one, so it gives me a graph, f of x, and says it's shown in the interval from 0 to 4. Explain why the area underneath the curve is more than 4 but less than 20. So if we're looking, Yes, ma'am. You just need one or you need two?
I just. Y'all learned calculus?
We are.
No,
It's a no. I'm moving on.
no, this is not. That's my time.
There you go.
I'll bring it right back.
Yeah, you
I can follow directions.
good. Well, they move them off of carts that are in the hallway, and they just put them in random rooms, and they're rooms that we didn't test in, and so, anyway, I got them all back this morning.
Good.
It happens. All right, so we're talking about the interval from 0 to 4, okay? And the area under the rectangle in that, okay, now I'm ready. In that interval. So at 0, what y value goes with 0? And then we've got 4. And so again, we go back to that range of 4. Okay, so if we're looking at those y values there. But if we think about why would the area under the curve be more than 4 but less than 20? Well, an area of 4 would just be this one. Okay. Is that enough to encompass the area of the whole curve? No, okay? This is too little. Okay? But then if we talk about less than 20, well, to get 20 for an area, I'd have to do 5 times 4. And what's wrong with that area? It's too much. Okay? We have all this extra space over here that we don't need. Okay? So it's a really big over approximation. All right, and the other one is a really small under approximation. So we know that that area, okay, can't be less or more than, that's why the area is more than 4 but less than 20. Y'all, I think it's like I haven't talked in 4 days. Okay, all right, so question, do we think the area under the curve is more than 8, less than 16? What do we think? Okay, well, let's talk about those areas. For an area of 8, it would have to be this one, 4 by 2. Okay, so that's an area of 8. Right, and then an area of 16 would be 4 times 4. Okay. So as we're looking at these, all right, what do we think? Is our area going to be more than 8, less than 16? Yes, no? Yes on both of those, okay? So it's got to be more than 8. 8 still leaves way too much area unaccounted for, okay? So if this is my actual picture, okay, that blue rectangle, it's still leaving a lot up there that's not covered, okay? 16, all right, it still looks like we have more outside of this rectangle than's left inside the actual curve under it, okay? So the answer to this is yes, all right? So it's got to fall between 8 and 16, right? So what it tells me to do on number 3 is like, okay, since you're so smart, all right, what would be that height on the y-axis, okay, that might give me the perfect balance, the perfect amount of stuff still under the curve and outside the curve, right? Well, we don't know. We're just going to have to guess. But my guess is it's got to be a little less than 4, and it's got to be more than 2. So I'm going to go with maybe right around here, 3.5. Would this be the perfect height? You know, I mean, I don't know. Okay. And it tells me to call that height C. Okay. So is that a perfect height that gives me the same amount of area in my rectangle as under my curve? That's what we're looking for. Okay. Do we have the same amount of area under our curve? So that being said, if we were going to find the area of our rectangle and my height is C, the base is always what? 4. So on that next page, right, what expression would give me that area? 4C. Okay, base is 4. My perfect height would be C. All right, so 4C. Now, the next one, it says write an integral expression that gives the area under the curve. All right, let's do that. If we write an integral expression, we're going from 0 to 4 of f of x dx. Okay. What we want to do is we want to figure out what is that perfect height. Well, if these two things have to be equal, the area of my rectangle is equal to the area under my curve, we would set those two expressions equal. All right. So they go a little bit farther in number 5, and it says, okay, here's one for you. We're going to give you the equation of f. Okay. We're going to give you the equation of f, and we're going to use that to find that perfect height c. Okay. So if we do that, I can do the integral from 0 to 4. Here is my f of x, negative x squared plus 4x plus 1 dx. So let's find that antiderivative. Okay. What would be my antiderivative for a negative x squared? Negative 1/3 x cubed. And my antiderivative for 4x, 2x squared. And my antiderivative for 1, x. But this time it's definite, so we're going to evaluate it from 0 to 4. Okay. Which value do we plug in first? 4. Okay. So 4 cubed would be 64. So I have negative 64 over 3 plus 2 times 16, which would be 32, plus 4. Okay. Now, this is not going to be a pretty number, all right, in the least, all right. Let's see, this is going to be 36 times 3, 108. Yep, minus 64, so negative 64 over 3 plus 108 over 3. 44? Yeah. Over 3, okay? That is the value of that integral, all right? It wants me to find c, okay? So to find c, we're going to take this expression. Well, we found this one, all right? We found the one in b. It's 44 over 3. Let's take the one in a. So 4c should equal 44 over 3, all right? How would I solve for c? I would divide by 44. So that should give me c equals 11 over 3. Okay, which would be about what? 3 2/3. Okay, and that's pretty close to where we put it. All right, so 3 2/3 would give me that perfect height for my rectangle so that the area under the curve would equal the area of that rectangle. Okay, that is what we refer to as our average value. Okay, it's what we refer to as our average value. So let's make a note over here. I want to add some stuff. Okay. If we're going to find, so if we have just some basic curve, all right, and we want to find our, or first of all, where did we get that for? Where did that come from? The width, right? Our x's were from 0 to 4. So how could we refer to that? Yeah, it's our interval. So we had 4 minus 0, so b minus a times c. This was the integral from 0 to 4 of f of x dx. So that's where it came from, okay? We set those two things equal. So we had 4c equaled this integral, 0 to 4 f of x dx. And then to solve, we divided by 4. Could I've also said 1/4 times the integral from 0 to 4 of f of x dx, right? We're going to generalize that here in just a second, okay? But we're looking for that perfect height, okay? That y value that's going to give me a rectangle, base times height, that's the same as the area under the curve. That is your average value, okay? Now, I think question 6 is interesting. It says, how does the value of c compare to all the values in that function? All right, to all the y values between 0 and 4, okay? What was the minimum y value in that function? 1. What was the maximum? 5. Okay. So obviously 3 2/3 is going to fall between your minimum and maximum. Your average value will always do that. Okay. It will fall between the minimum and maximum. Okay. So if you're doing a problem like this, and you know that the maximum y value is 4 and the minimum is -2, and you get an average value of 10, you did something wrong. Okay, it's going to always fall between the maximum and minimum value. Okay, those are y values, all right, not x's. All right, so important to remember, those are y values. All right. Now, I really like to use this illustration. I copied this, screenshot it from my phone, all right, of my average steps the week of the 17th through the 19th. Or I guess that's a month, isn't it? Yeah. Okay, of that month. And so in that month, I was averaging about 8,000 steps a day, all right? So you can see the up and downs, all right? My guess is this is a Saturday or a Sunday where I didn't move. Okay, that was a couch day, all right? The taller ones are probably the days that I teach dance, all right, because I get a lot more steps on those days, all right? But it looks like my minimum is at 0 steps, or my minimum is a little over, probably a couple, 100 or so. And then my max is right up at 15,000, all right? So if we think about this in terms of a function, all right, in terms of a function, the function would look something like this. I mean, this is a function we don't know a whole lot about, okay? And it tells me the average y value is hitting at about 8,300. So that means if I've got 8346, right, that this purple rectangle should have about the same area as what would be under the black, the squiggles, the function itself. Right. Now, this one happens to start at 0, but let's just call it A because it doesn't necessarily have to start at 0. Okay, our interval could be anywhere. Right, it could be anywhere. And so we're looking for where, all right, so this would be my C value, where the purple area would equal the area under the curve. Okay, let's start with the area under the curve. How would I get the area under that black curve? Integral from A to B of f of x dx. Okay. How would I get the area of the rectangle? C times B minus A. Okay? C is our average value, so I'm going to solve for it, which means I'm basically dividing by B minus A. All right? That's the same thing as 1 over B minus A times the integral from A to B of f of x dx. And that is your formula for how to find average value. Okay, that's it. That's your average value formula. So anytime they ask you for that, that's what we're looking for. Okay. And the thing to remember about average value, you're looking for the height of the perfect rectangle. So that area of the rectangle equals area under the curve. Okay, that's what we're doing when we're finding average value. Now, good news. This is the only thing we're going to use today. We're going to use it in lots of different ways, but it's the only thing we're going to use today. Okay? All right, here we go. So let's look at this one. Ooh, BOGO burritos at Chipotle. Are y'all Chipotle fans?
Well, I've never been to Chipotle.
Have you not? They're proud of their food, as my grandmother would say. It's a little too expensive.
Someone told me that Chipotle is getting bankrupt.
Oh, I think most things are going bankrupt right now, to be honest with you. Okay.
Keep going.
Listen, if we ever lose McDonald's, y'all need to know it's bad. Okay. Or Waffle House, like they're everywhere. I've heard they're going to convert the Highway 55 to a Waffle House. And if that happens,
I'm all for that.
I am all about it.
Highway
I've
55
never
is
been to Waffle House.
3 minutes from my house.
Jawok. Oh, all-star breakfast. Eggs, hash brown, waffle, toast. Oh, you got to have it. I mean, I can only eat like 2 bites of all of that now, but it would be so good. Okay. Sorry. Food gets me that way. All right, so let's take a look at this one. First thing they want me to do, okay? So BOGO burritos on Teacher Appreciation Day, if you're willing to stand in line. On this particular day, the number of people waiting in line to order is modeled by W of T. So there's a function where T is measured in hours since Chipotle opened at 11 a.m. Write an integral expression that would give the average number of people waiting in line at Chipotle from noon to 6. Okay, from noon to 6. So we just want to write the expression for average value. Okay, so let's think about it. T is hours since they opened at 11. Okay, so if we're doing noon to 6, what are our T's going between? 1 and 7. Okay, 1 and 7. So when we do the average value expression, all right, 1 over b minus a times the integral from a to b of f of x dx. Well, let's just plug in what they gave me, okay? B minus a, what would that give me? 6. Integral from a to b, so 1 to 7. Oh, thank you. Need me to sign it right now? Oh, I don't have a pen. Oh, you're so, see, this, people take care of me. Life is good. Thank you, buddy. I appreciate you. Okay, so 1 to 7. Now, what was my function they gave me? W of t. What's going to be my, what's going to go after that? dt, okay? This would be an expression, okay? This would be one of those questions where if we didn't get the boundaries correct or we didn't get the dt on there, we would probably lose a value, okay? We'd lose a point. So all this one wanted was you to write an expression, okay? Average value expression. Question about that one? Okay, let's look at the next one. It says to find the average value of this function on the interval from 0 to 3. Does f actually take on this value at some point in the interval? So let's walk through that. Let's set up the average value. Bless you. Okay, so what's my fraction in front going to be? 1/3. Integral from 0 to 3. 4 minus x squared dx. Let's take our antiderivative. You're going to keep that 1/3. Okay. What's your antiderivative going to be?
4x minus 1/3 x.
Good. And we're going to evaluate it from 0 to 3. Okay. So if we plug in the 3, I'd get 1/3 times 12 minus 3 cubed is 27. Divided by 3 would be 9. What about if I plug in a 0? They're all 0, yay. Okay, but we would actually plug those in. We'd get 0 minus 0, okay? So if we simplify that, 12 minus 9 is 3. 1/3 gives me 1, okay? So that is my average value, Okay, so that's my average value C. The question is, does the function actually equal 1 at some point? Okay, let's answer the second part. So that's a y value, so it goes in for f of x. All right. Does it equal 4 minus x squared? Well, let's see. All right, if we subtract the 4, we get a negative 3 equals a negative x squared, or x squared equals 3. If I take a square root, typically we would get how many solutions? 2, but it's only asking me about the interval from 0 to 3. Okay, so I only need the positive solution. So can x equal square root of 3 between 0 and 3? So the answer is yes. Okay, so we just took that y value that we found and we plugged it in for y in the equation. All right, terrible.
So, because x is less than 3 when you solved it, that
Mm-hmm.
was going to,
Yep. Okay, as long as it falls between 0 and 3 for that x value, we're good.
oh, okay.
Hmm?
She must not give them up because it's between the two values.
Well, you would think so, but yeah. Okay. All right, let's look at another one. All right. Oh, too far. All right, let's look at this one. Y'all do this one. This one just wants you to find the average value. Okay. Some antiderivatives, little trig there for fun.
I was second guessing myself.
Okay. Let's see how we did. B minus A, right? A little bit tougher, all right? Negative pi over 2 to pi over 2. So pi over 2 minus negative pi over 2 is 2 pi over 2, which is just pi. Okay? Or if you think about the unit circle, negative pi over 2 is at the bottom, pi over 2 is at the top. That's a distance of pi. Okay? So 1 over pi. Let's do our antiderivative, which is going to give me 1 over pi times 2. What did I start with to end up with cosine? Sine. And we're going to evaluate that from pi over 2 to negative pi over 2. Just some good trig right here. So are y'all good if I make that 2 over pi? Sine at pi over 2 minus, I distribute it, 2 over pi sign at negative pi over 2. Okay, sign at pi over 2. 1, so I have 2 over pi times 1 minus 2 over pi. Sign at negative pi over 2, negative 1. So plus positive, that gives me 4 over pi. Okay, so that is my average value. Okay, let's do this one. I'm so excited. Okay. All right, what's going to get more complicated? The antiderivatives. Okay, that's what's going to get more complicated. So let's take a look at the next one over. Flip that page. Oh, too far. You see now? I see, said the blind man. All right, so we're going to find the average value of the function e to the 3x minus 3 minus 4x on this interval from 1 to 3. What's my b minus a going to be? 2. So I have 1/2 times the integral from 1 to 3 e to the 3x minus 3 minus 4x dx. Now, this is a little bit more complicated integral, all right? And because I've got that e to the 3x minus 3, that's definitely a composition, all right? So what I'm going to do is I'm going to keep that 1/2 out in front, and I'm going to split this into 2 integrals, right? Minus 4x is no big deal, okay? But that integral from 1 to 3 of e to the 3x minus 3, that one is a big deal. 1 to 3 e to the 3x minus 3 dx minus the integral from 1 to 3 of 4x dx. All right, so I'm going to leave it like that. I'm going to separate it using my properties of integrals. Okay. Now, looking at the first one, because it's something other than e to the x, right, that integral has to include the derivative of that exponent. What would the derivative of that exponent be? It'd be just a 3, okay? That I can fix. I don't have to do u substitution. So if I put a 3 here, what would go in front of that integral? 1/3, okay? The 4x, not a problem at all, okay? So I'm going to keep this 1/2. When I do the integral, right, I'm going to keep the 1/3 that was in front. I'm going to get the e inside because derivative of e is e. So e to the 3x minus 3. And we're going to evaluate that piece from 1 to 3. I'll actually put a second bracket in there. Okay. Minus, right, integral or antiderivative of 4x. 2x squared. And we're going to evaluate that from 1 to 3. Okay. So we've got 2 different things that we're doing there. Because we're doing them both from 1 to 3, okay, we can also do this. 1/2, 1/3 e to the 3x minus 3 minus 2x squared evaluated from 1 to 3. Okay, so just to take some of that grouping out, all right? We're evaluating them both, all right? So we just did the integral separate, all right? If it makes you feel better to distribute the 1/2 before you start, you can. Right? We can distribute the 1/2 or we can just evaluate it as is and divide by 2 in the end. Right? So your choice. Right? So 1/2. Let's see. So I would have 1/3 e. 3 times 3 is 9 minus 3 to the 6th minus 2 times 3 squared, so minus 18. Minus, if I plug the 1 in, 1/3. 3 minus 3 gives me e to the 0. Minus 2 times 1 squared, which would be 2. All right. I would definitely use a calculator at this point, or we could just leave it exact. All right. So I have 1/2 times 1/3 e to the 6th minus 18. What is 1/3 times e to the 0? Minus 1/3, and then minus a negative 2 would be plus 2. So I have 1/2 times 1/3 e to the 6th Minus 16 minus a third. I'd probably use a decimal approximation. I didn't tell you that was a calculator active. Okay. So I think you get 59.071. Okay. Here's the main thing I need you to get out of that, because at this point I think you understand the average value formula. It's pretty straightforward. The tough part right here was in that second blue step, all right, where we had to do that integral and we had to balance that 3, okay? We had to balance that 3 in there. It was a composition, right? And because it was just a number, we could fix it, right? Question on that one. All right, the one below is from a released exam. All right, so it's actually from a released exam. It's pretty old because it's got 5 answer choices. All right, so it wants to find the average value of y equals x cubes, or x squared cube root of x cubed plus 1 from 0 to 2. Y'all try it, okay? It's non-calculator. Did a new water flavor today. It tastes like suntan lotion.
Are they good way or bad?
Bad way. It was a strawberry, pineapple, and coconut. Nope. Definitely suntan lotion. So this integral is a little wonky, right? Do we have a composition in this one? Is there something inside something else? Yeah, okay, this is definitely a composition. This is x cubed plus 1 being raised to the 1/2. Okay, so if we think about it that way in terms of composition, what would be the derivative of that inside? 3x squared, okay? So we're close. We have x squared in front, right? What are we missing? That 3. So if I put a 3 in front, how are we going to balance it? A 1/3 on the outside, okay? So now I have 1/6 times the integral of from 0 to 2 of 3x squared square root of x cubed plus 1 dx. So we've balanced that constant, okay? It gave me the x squared, which was nice. Derivative of x cubed is x squared, 3x squared, so we have that. Now, when I do my antiderivative, we're thinking about this in terms of composition, okay? In terms of composition, so be careful here, okay? What we have is something to the 1/2, all right? If I take the antiderivative of something to the 1/2, what power is it going to go to? We add 1. Okay, antiderivative. So we add 1 to 1/2, we would get what? 3/2, which means we'd have to multiply by 2/3. And my thing I'm raising to the 3/2 is that x cubed plus 1. It was that inside stuff. Okay? So now if we simplify, this gives me a 1/9 times x cubed plus 1 to the 3/2. And we're going to evaluate that from 0 to 2. Okay. If I plug in 2, 2 cubed would be 8, plus 1 would be 9 to the 3/2. Minus, if I plug in 0, 0 cubed would be 0, 1 to the 3/2. Okay, what does it mean for something to be to the 3/2 power? Cubed and square root. I like to do that opposite. I like to square root it, then cube it. All right, because if I square root first, it gives me a smaller number. Okay, so let's square root first. Square root of 9. 3 cubed, 27. Square root of 1, 1 cubed, 1. And so that gives me 26 over 9. Okay. You don't like it? Right? Now, we could have done this problem with u substitution, so I'm going to actually erase it and do it that way. All right, so that you have two things, all right? So if you need to shrink it out, go out another direction or whatever, but I'm going to erase and do u substitution, okay? You can avoid u substitution if you understand about composition, all right? But a lot of us did better with u substitution, okay? So I want to show you that as well, okay? All right, are we ready? Okay. I got this before I erase it. Okay. Okay. So, u substitution says this, right? We recognize that we've got a composition function here. So I have 1/2 integral from 0 to 2 x squared square root of x cubed plus 1 dx. Okay? And u substitution says this. It's like, okay, what's your inside stuff? Well, it's x cubed plus 1. What's your du? 3x squared dx, right? And so we're going to rewrite. The only problem is I don't have a 3 in there, okay? I don't have a 3 in there. I've got an x squared and a dx, and I've got an x cubed plus 1. So what I'm going to do, 0 to 2, x squared, nope, taking that out. X squared dx is my du. X cubed plus 1 is my u, and I'm going to raise it to the 1/2. Okay? This is where we balance the 3. So we put a 3 in there and a 1/3. So you're still going to have to do that part, all right, because it's missing. But I can simplify the integrand. Now, when we do u substitution, there's this trick that we can change the boundaries. Okay, do you remember that? When I do u substitution, I can change the boundaries and I never have to put u back in. All right, so if I go in and I change those boundaries, all right, they come from over here. Okay, I plug in 0 for x, so 0 cubed plus 1 gives me 1, so my bottom boundary is going to become 1. Okay, I plug in 2 cubed plus 1 gives me 9. Right, so now I'm left with 1/6 u to the 3/2, and we're going to evaluate it from 1 to 9. All right, and if you notice, that's what I had after I integrated. Okay, so when I plug it in, I get 1/6 times 9 to the 3/2 minus 1 to the 3/2. So when you do u substitution with a definite integral, you have to rewrite those boundaries. So I have 1/6 times 27 minus 1, or wait a minute, I did something wrong. The 1/2 was already there. 3 1/3. 1/6. Oh, I don't, okay. No. Yeah, what'd I do wrong? Oh, I forgot to divide by the 2/3. Yeah, I forgot that part. When I did u to the 3/2, there'd be a 2/3 right there. I was like, what am I missing? Okay. So it's 1/9. Sorry. There we go. 26/9. When I did my antiderivative, I forgot to divide by the 3/2. Okay. So there's where your 2/3 comes in. All right. So 2 different ways to do that one. Okay. If you're not good with either one, you need to pick one. All right. And focus on that one. All right. Yeah. Lock in on one. All right. And make sure we get that, because you're going to have lots of things that are going to need, they're going to be integrals of compositions. All right. It's just going to continue to show up. All right. Let's get to the calculator active stuff. Okay. You're going to want your calculator. All right. Because these are mainly in the setup, and then we use our calculator to do the rest. No, but I gotta finish it. I need like another something in there, something sweet. It's way too tart. It was the aftertaste. Like, legit, I feel like I had licked a suntan lotion. I'm gonna guzzle it fast and get it over with. Okay. So it's a piecewise function. Y'all know how much AP loves that kind of mess. Okay. And so it says a 12,000 liter tank of water is filled to capacity. At time equals 0, water begins to drain out of the tank at a rate modeled by R of T, measured in liters per hour, where R is given by the piecewise defined function. Find the average rate at which water is draining from the tank between times T equals 0 and T equals 8. So now let's think about this. Because it's piecewise and we know we're doing average value, okay, how many integrals is it going to take? 2. Okay, so we're going from 0 to 8, so I'm going to have a 1/8 out in front. What we're going to do then is split that integral. For the first piece, it's going to go 0 to 5, 6,000 divided by t plus 3 dt. Plus, in the next one, it starts at 5. We're going to end it at 8. And it's 1,000 e to the negative 0.2 t dt. All right, you're going to use your calculator to type it in. All right, 1/8 parenthesis, math 9. Close all that out, plus math 9. Close it out. All right, and it will give you your answer, which I did not write down. We'll compare with your table partners. We'll see. If we get 9,000 different answers, we'll know. I actually don't have the correct answer in front of me, so it's going to be accuracy by commonality, I guess. Because I didn't type it in.
Oh wait, yeah, this is fixable. This is fine.
This is funny. Okay, so I'm going to have to type it in, aren't I?
I got 177. I got 2.
All right, we're getting 258s.
That's 3 so far.
All right, 4 258s.
Okay, hold on. I can fix this. This is fixable.
Yep, it's fixable.
Okay.
You know, you can copy paste. Highlight it, arrow up, highlight it, hit enter, it'll copy it back down. And then you can just arrow in and change what you need to change. right, give me that number so I have it in my notes this time.
258.053.
I got space.
Alright, I'm not alone.
I'll stand by.
I always say that I see
I'm pretty sure.
You got 258.
250, that's it, but.
Yeah, because plus, yeah, I did it there. I did it right.
Yep. What'd you get?
I put a 6 the first time after the A on the second interval though.
Do what?
I put a 6 the first time I did it.
No.
On the second interval.
Huh? Can I see your?
Oh, did you?
Yeah. It was like, but it doesn't have five, so it's
I know, but you've got to touch, but you got to, for the integral
Yeah.
properties to work, you got to connect them.
that makes sense.
Wait, home, did you get 258? I ain't not as well, because I got 177.
You should just give that.
Oh.
Golly, brutal.
This is why he's not Team Adams family. He's not.
It really is a funny show. It's funny. It's good.
Exactly, which is why you should watch it.
You're one.
D12 is still an open seat. It's not.
I don't know if you're only getting 150.
258?
150, whatever.
They're getting like one side.
I got one. Yeah, James and I got 177.
Yeah, because you need added two for the 600.
I had 256.
You do
Yeah, you didn't add the X on the 600.
Is there an X?
Yeah, there is.
Oh, okay, that's on me.
Oh. Alright, my bad.
because y'all just didn't check as much work.
I know, you'll have to check me. Y'all know I'm crazy. And apparently today I'm really struggling.
Yeah, it's yeah. For Pete's so trusty, how could he
Sorry.
silly us?
I hate to disappoint you. It's just proof that we all make mistakes. Everybody has those days. Per Hannah Montana. Y'all have aged out of Hannah Montana, haven't you? I need to hush because, okay. It's all good. Rebecca was so excited at one of her, I guess she was 4. She got Hannah Montana hair. It was awesome. We went to see Miley Cyrus in concert before she lost her mind. Like, it was great. Okay. We better now? That I wrote the problem down correctly? Okay. So, let's look at the next page. I want you to notice these are going to appear primarily in a free response question. Okay? So, here's one. All right, the next two are portions of released free responses. All right. So it says on a certain weekday, the rate at which vehicles cross a bridge is modeled by this differentiable function, where R of T is measured in vehicles per hour, and T is the number of hours since 7 a.m., so that's time 0. Selected values are in the table. On a certain weekend, the rate at which vehicles cross the bridge is modeled by the function H, where H is measured in vehicles per hour and T is measured in hours since 7. According to this model, what is the average number of vehicles crossing the bridge per hour on the weekend day? Okay, so notice what all they gave you, all right? The top one is the weekday. The function is the weekend, all right? So do I even need that table? No, okay? I don't even need it. I probably need it for another question, but I don't need it for this one, all right? So that's why reading is so important. We can't just assume aside that they want me to use the table, all right? So see if you can do 7 for me real fast. It is calculator active. It is calculator active. All right, we're going to put h of t in, so be careful you don't miss any negatives there. Negative t cubed minus 3t squared plus 288t plus 1300. Okay, I also think they give you some distractors in here as well. This 0 to 17, that's what the function's defined for, but the time they want me to do is 0 to 12. Okay, so you just have to be careful with those kinds of things. I don't know if there's decimals attached to that. That's what I have written down right there. 2452, is it exact?
Yep.
Okay. And that would be vehicles. Okay. How many are crossing? About that many. All right. Question about that one. So when it's calculator active like that, that's what they want you to do. They do not want you to do it by hand. They want you to plug in the function, right, and use your calculator to do it, right? Now, let's look at the next one. This is good because it's going to force us to go back and remember something else we haven't done in a hot minute, okay? So it's a really good question. It says the temperature of water in the bathtub is given by WT, a strictly increasing differentiable function, all right? We're going to do two of the parts of this question. It's probably important that they told me it was increasing, all right? Probably has something to do with overestimates and underestimates, if I had to guess, okay? So it says use a trapezoidal sum with 4 subintervals indicated by the table to approximate 1 over 20 times the integral from 0 to 20 of WT dt. What did they just give you in that expression? What are they asking you to find? The average value, okay? We know that because of that fraction in front, all right? It's going from 0 to 21 over 20. We're going to need that for part B, all right? But the first thing they want me to do is a trapezoidal rule, so I'm going to keep the 1 over 20. Now, we've not done a trapezoidal rule in a hot minute, okay? In a hot minute, all right? So let's think about it for just a second. How do we find area of trapezoids?
1/2 base 1 plus base 2 times the
You got it, okay? So they're going to all have a 1/2, okay? The bases are my y values, okay? So 55 plus 57.1. What is the height of that one? 4, okay? So x's give you your heights, y's are your bases, okay? Then we go to the second trapezoid. We're going to do this 4 times. 1/2, my bases, 57.1 plus 61.8. What's the height of that one? 5. Plus, do it again, 1/2. Basis 61.8 plus 67.9. And what's my height? 6. Okay. Plus, we're going to do it one more time. 1/2. 67.9 plus 71. And what's my height? 5. And that's what we'll put on the calculator. It is all arithmetic. Okay, it is all arithmetic. It's just asking me for that value. Did y'all not get that? Did you get 62? Okay, it's because I did it wrong. I typed in something wrong. I thought I had that one. What is it, 62 point? Okay. Right. Yeah, I had an asterisk next to it. I need to learn if that means I did it wrong. Okay. All right. So now it says, let's explain what that is. Okay. Using proper units, let's interpret our answer. You just told me that's the average value. Okay. Well, the value we're talking about is the temperature. So we would say the average temperature of the water between T equals 0, and what was T referring to? Minutes. And T equals 20 minutes. Okay, the average temperature is 62.89 degrees Fahrenheit. Okay, so you want to use all the units for time and the units for temperature, along with that it's average value, right? Okay, let's do 2 more. We're going to call it done. All right, so just trying to show you all the different ways they can ask you questions about all this good stuff. All right, but they're using the same formula every time, which is nice. Okay. All right, last one, or next to last one. It says the average, I don't know why there's a 1 right there. I probably copied it from something. The average value of function f over the interval from -1 to 2 is -4. The average value of f, same function, over the interval from 2 to 7 is 8. What's the average value of f over the interval from -1 to 7? Okay, so here's what we're trying to find. The average value from -1 to 7, what would be my coefficient out in front? 1/8. Okay, we're going to go from -1 to 7 of f of x dx. That's what we're trying to find. Okay, now how do we get there? Well, let's talk about what we know. We know that the average value from -1 to 2 is -4. Okay, so from -1 to 2, what would be the coefficient in front of that one? 1/3. Right, of f of x is equal to -4. The other thing we know is that the average value from 2 to 7, so that would be 1/5, the integral from 2 to 7 of f of x would equal 8. So do we agree about that? Okay. Now, using our properties of integrals, right? I think we could do this. We've got an integral here from -1 to 2 and from 2 to 7. So to go from -1 to 7, it would be the integral from -1 to 7 of f of x. Nope, -1 to 2 of f of x plus the integral from 2 to 7 of f of x. Okay, we'd have dx's on there, right? The problem is I don't have those integrals isolated because they have coefficients in front of them. How could I get rid of those coefficients? Multiply. So this gives me that the integral from -1 to 2 of f of x is going to equal -12. So it's going to give me that value. This one, if I multiply by 5, the integral from 2 to 7 of f of x is going to equal 40. All right, we just multiplied. Now I can replace it in my average value, -12 plus 40, or 1/8 times 28, okay, or 28 over 8, which would be 7/2. Okay, so that one's using what we know about average value, what we know about properties of integrals, like covers a lot of standards, very AP-esque. Okay, covers a lot of things. Okay. All right, last one, best one. I don't think Oakley agrees. I saw you down there getting ready to throw things yesterday as I was leaving. How's that going? It's fine. Okay, just don't start throwing pencils and stuff in here. We'll be okay. All right, so it says to find the average value of f on the interval from -4 to 4 of f of x. Okay, so if we set that up, average value, what's my coefficient in front? 1/8. Okay, we're going to go from -4 to 4 of the square root of 16 minus x squared dx. Now, at first glance, looking at that, I'm thinking, oh, it's a composition, right? I've got something under a square root, might need u substitution. The only problem is if I let u be 16 minus x squared, what's du? 2x dx, and there's no x whatsoever in that integral, okay? So we can't do it that way. We have to get creative, okay? We don't know the math yet to be able to do that integral. Do you know what 16 minus x squared looks like on a graph? It's a semicircle. Let's use geometry, okay? If I know what it looks like on a graph, we can use geometry. It's centered at the origin. It has a radius of -4 to 4, okay? And it looks like this. All right, and so I can do that integral from -4 to 4 as an area. So the area would equal half pi r squared, all right, because it's a semicircle. So it would be 4 squared would be 16, so it would be 8 pi. All right, so that's the value of my integral. So I have 1/8 times 8 pi, and what's my average value? Just plain old pi. Okay, so that one to me actually turns out to be easier than a lot of the others because I can just use geometry. It's a semicircle. Okay. What questions do you have? All right, well, here it is. I gave you a worksheet today. It's called 8.1 Practice Problems. They were adapted from AP Classroom. Okay, you don't have to do them all, but here's some good ones. 2, 4, 5. 6, 7, 10, 11, 12, 13, and 14. Okay, so those are good ones. And you do have a wrap up today on Google Classroom, so let's get that done. Get us a point this week.